Hey guys, because this is your first test with me, I want you to know exactly what to expect for this test. So I am giving you a sample test. So this test is going to look remarkably like your actual test. The actual test will be typed. I'm going to change a 2 to a 3 or an X to a Y and ask you the same types of questions. Not everything that's on the sample test will be on the actual test. This is a little longer than the actual test will be, but you're not going to see anything on the actual test that you don't see on the sample test. So as long as you know how to do everything on the sample test, you'll be good to go. We're going to work through it together in class. And I'm going to give you worked out solutions for it to take home to use and study, but also making these videos for you in case there's something that you missed that you want to go back and review back over. All right, so for number 1, they asked us to simplify 3 to the 6th times 3 to the 2nd. When your bases are the same and you're multiplying, remember that you're going to add your exponents. So we're just going to add the 6 and 2, and that would leave us with 3 to the 8th. Now, you could leave that as 3 to the 8th, or you also could look at your little chart and see what 3 to the 8th is and give that value. Either one of those would be fine. All right, then for number 2, we are simplifying 5x cubed y to the 5th times negative 7x to the 4th y. So first, I'm going to go through and collect like terms. So I'm going to collect my coefficients, and I'm going to collect my x's, and I'm going to collect my y's. All right, so 5 times negative 7, of course, is negative 35. And then again, when your bases are the same and you're multiplying, we're going to add those exponents. So that's going to give us x to the 3 plus 4, or x to the 7. And then same thing, the exponent on this y, when there's no exponent there, that's an understood 1. So we're going to say 5 plus 1, and that's going to give us y to the 6th. All right, then for number 3, we were working with scientific notation. So please remember in scientific notation that your first number has got to be a single digit. So it's going to be larger than 0 and smaller than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and in a whole number, your decimal is at the end of the number. So I'm going to need to move that decimal 1, 2, 3, 4 places for it to be in between the 3 and the 7 to give me that 1-digit start that I need on a scientific notation number. And so that's why we are raising this to the 4th power. Now, remember that when you multiply by something by 10 to a positive exponent, it's going to make that number bigger. So if we take this and multiply it by something to a positive exponent, it's going to make it larger like we've got here. If this were a negative exponent, then when I multiply something by a negative exponent, it's going to make it smaller. All right, let's go the opposite way. Let's say they gave me the scientific notation and I want to give the standard form for that. And so for this one, as we were saying a second ago, when you have a negative exponent, that is going to make your number smaller. And so we've got 8.3, and we're going to move that decimal 3 places to the left. So we're going to go 1, 2, 3. Now, when we moved it 3 places to the left, so again, it was right here, so we moved it 1, 2, 3. We had 2 open spots that we had to fill with 0 placeholders. So again, just kind of checking back over our work when we're done, we should see that when we multiply by a positive exponent, the number gets larger. When we multiply by a negative exponent, the number gets smaller. All right, we also can multiply 2 values. So for instance, 3.5 times 10 to the 4th and 4 times 10 to the 3rd. So again, I'm going to collect my coefficients, 3.5 times 4, and I'm going to collect my 10 to the 4th and 10 to the 3rd. All of these were being multiplied, 3.5 times 10.4 times 4 times 10 to the 3rd, and we can multiply in any order, so that's why we were able to collect our coefficients and collect our powers of 10. All right, so 3.5 times 4 is going to give us 14. You could do that on your 4-function calculator that you'll be able to use for the test. And then here again, when your bases are the same and you're multiplying, you're going to add your exponents. So we would add the 4 plus 3, and we would get 10 to the 7th. Now, this is not in scientific notation just yet, because remember that the first number has got to be a single digit, something larger than 0 and smaller than 10. 14 is not smaller than 10. So right now, my decimal is at the end of that whole number after the 4. I need to move that decimal one place to the left, and so that's why our exponent is going to go up 1 from 7 to 8. All right, then for number 4, when our bases are the same and we're dividing, we subtract our exponents. So we're going to have 8 minus 3, so 6 to the 5th. And again, you could look on your chart and give the value for that if you preferred, or you could leave it as 6 to the 5th. All right, for number 5, I'm going to start off by collecting like terms again. So I'm going to put my coefficients together, 36 over 4. I'm going to put my powers of A together, and I'm going to put my powers of B together. All right, so 36 over 4 is 9. Remember that when your bases are the same and you're dividing, you subtract your exponents. So that's going to be 6 minus 6. And here that's going to be 9 minus 3. All right, so 6 minus 6 is going to give me a to the 0. 9 minus 3 is going to give me b to the 6th. And remember that anything to the 0 is going to be 1, with the exception of 0 to the 0, but we don't have to worry about that here. And so a to the 0 is going to give us 1 times b to the 6th. So 9 times 1 times b to the 6th is 9b to the 6th. All right, similarly for number 6, I'm going to simplify anything that I can inside my parentheses first before I raise this to the third power. So you can see 7 over 21 would reduce to 1/3. And then there were no other like terms in my variables that I could simplify down. So let's go ahead and let's apply that 3 to every one of these things in parentheses. So again, 7 over 21 became 1/3. So there's 1/3 to the third. All right, then we're going to do j to the 2nd to the 3rd. So you see that right here. K to the 4th to the 3rd here. And then L to the 5th to the 3rd here. All right, so if we simplify, 1 to the 3rd is 1. 3 to the 3rd is 3 times 3 is 9 times 3 is 27. When you have a power raised to a power, you multiply your exponents. We had said that this little parenthesis here might help us remember to multiply, because parentheses usually indicate multiplication. So 2 times 3 is going to give us j to the 6th. 4 times 3 is going to give us k to the 12th, and 5 times 3 is going to give us L to the 15th. So then we can combine our numerators and denominators. You don't need to leave that 1 in the numerator as a coefficient, because 1 times anything will be that other thing. It is the identity of multiplication. So if it's in simplest terms, I don't need to include that. All right, then for number 7, we're going to do something very similar to 6. And remember that we said we want to simplify inside the parentheses first before we raise it to that exponent. All right, so for number 7, we're going to simplify inside our parentheses first. So I could say m to the 3rd over m to the 2nd. When your bases are the same and you're dividing, we subtract our exponents. And p to the 2nd over p to the 1st, because again, when there's no exponent, there's an understood 1. So p to the 2nd divided by p to the 1st. When our bases are the same, we subtract our exponents. So m to the 3 minus 2 would give us m to the 1. Our n to the 5th stayed the same, and then p to the 2 minus 1 would give us p to the 1. So this is definitely easier to raise to the 4th power than what we had up here to begin with. All right, so let's go through and let's take our 3 halves to the 4th power, our m to the 1st to the 4th power, our n to the 5th to the 4th power, and our p to the 4th power. So we've broken those all apart here to make them easier to see. So you can look at your little chart and see that 3 to the 4th is 81 and 2 to the 4th is 16, or you can multiply those out. When you have a power raised to a power, you multiply your exponent. So 1 times 4 is going to give us 4. 5 times 4 is going to give us 20. And 1 times 4 is going to give us 4. All right, for number 8, again, that same rule. When you have a power raised to a power, you're going to multiply your exponents. It doesn't matter if they're positive or negative. So negative 4 times negative 8 would give us a positive 32. And then for number 9, I'm going to go through and take each one of these and raise it to the power. So 8 to the 6th, x to the 4th to the 6th, and y to the 5th to the 6th. So when we break it apart into those separate pieces, it just makes it a little bit easier for us to work with. So we can say 8 to the 6th is 262,144. And then power raised to a power, we're going to multiply and get x to the 24. And again, power raised to a power, we're going to multiply and get y to the 30th. All right, for number 10, we're going to start off with dealing with this square. So we have to take care of the exponent first before we can combine these. So let's go through and let's raise every one of these to the second power. So we'll have negative 5 squared, x to the 3rd squared, y to the 4th squared. All right, so negative times negative is positive. 5 times 5 is 25. When you have a power raised to a power, you multiply, so that's x to the 6th. When you have a power raised to a power, you multiply, so that's y to the 4th. All right, so now we've taken care of this first piece. Now we can multiply our monomial times our other monomial. So 25 times 4 is going to give us 100. And then x to the 6th times x to the 1st, we're going to group our x's together. Y to the 8th times y to the 5th, we're going to group our y's together. And so when your bases are the same and you're multiplying, you can add your exponents. The exponent here is 1, so 6 plus 1 is going to give us 7. And then our bases are the same and we're multiplying, so we can add our exponents, so 8 and 5 is going to give us 13. So there's our final answer, 100 x to the 7th, y to the 13th. All right, then for number 11, remember that anything raised to the 0 is equal to 1. So other than 0 to the 0, but we don't have to worry about that here. All right, then for number 12, I'm going to go through and break each one of these apart. So we've got a to the negative 3rd over 1. We've got b to the 5th over 1. And then c to the negative 4th is in the denominator. So that's going to be 1 over c to the negative 4th. All right, remember that when you have a negative exponent, that you have to use the reciprocal. We said to get rid of the negative, you're going to move across the division bar, because the reciprocal of a to the negative 3 would be 1 over a to the positive 3. So we're going to move across the division bar and get rid of that negative exponent. This one was already positive, so it can stay where it is. But this one is negative, so again, to get rid of that negative exponent, we're going to use its reciprocal, and we're going to move it across the division bar. So now in my numerator, I've got 1 b to the 5th, c to the 4th, and in my denominator, I've got a cubed times 1 times 1.